Okay, continuing with the Worksheet 6 review, we're on number 34. Another couple of graphs that were given. As x approaches negative 2 from the left, negative 2 from the left. For h of x, we're going to get, okay, here's h over here. Okay. Negative 2 from the left will be a 2. And minus g from, as x approaches negative 2 from the left, that's a 6. So this is negative 4. Okay, negative 2 from the right. For h, negative 2 from the right is 4. Plus 2 times, as we approach negative 2 from the right of g. Negative 2 from the right of 3 is 3. 2 times 3 will be a 6. 6 plus 4 is 10. 2 from the right for h, 2 from the right is 0. 2 from the right on g is 3, so this is 0. It's fine to have 0 on top. Okay. For number 37, negative 3. So 2 times, as x approaches negative 3 of h, negative 3 for h will be a negative 3 times negative 3 on g. Negative 3 on g is a 3. So this ends up being negative 18. G of 5 is 4 plus the limit as x approaches 5 of h. Limit as x approaches 5 on h. Oh, there's a jump there. That does not exist. So I get rid of that and I just say this does not exist. There's a jump there. X approaches 2. For g, as x approaches 2, that's 3. For h, as x approaches 2, that's a 0. That is not good. I'm going to get rid of that and say this is a DNE. Does not exist because you can't have 0 on the bottom. Don't say, though, this is important, do not say that the limit is something over 0. Get rid of that. That's just not true. It's bad notation, bad. Okay, limit as x approaches 2 of g of h of x. G of h of x. So first I go into h. H of x as x approaches 2. Okay, that's going to be 0 from above. 0 from above. So this will be the limit as x approaches 0 from above of g of x. And as x approaches 0, well, it's always 1 whether we approach it from above or below. So it's always 1 whether we approach it from above or below. But we really are only looking at from above right here. But either way, that's equal to 1, so this is 1. Make a limit using both g and h, and then find your limit. I'm going to let you guys do that one. All right. More limits algebraically, where you show me your work. If I put a 3 in for x, I get 0 over 0, 0 over 0. And so I have to manipulate this. I am going to multiply top and bottom by 3x to get rid of those little denominators. Oh, that's my bad pen. Out of ink. The limit as x approaches 3. Okay. 3x times 1/3 is x minus 3x times 1 over x is 3 divided by 3x times x minus 3. I do not want to distribute that because now I can get rid of my whole. Alright? So now I can get rid of the whole, and you can cancel these out because x is not 3. X is only approaching 3, so we can cancel those out. Put 3 into the remaining x, and we get 1 over 9. X is approaching 1. I have 0 on the bottom. If I put 1 in here, I have 3 over 5. 3/5 minus 3/5 is 0. 0 over 0. Once again, there's a hole. It's just hidden. I'm going to multiply both top and bottom by the product of the little denominators. 5 times x plus 4. So I have limit as x approaches 1 of, okay, for the first one, the 5's reduce out, and I'm left with 3 times x plus 4 minus 2 plus x times the x plus 4 is reduced out, and we're left with that 5 there, divided by x minus 1 times 5 times x plus 4. I'm not going to multiply those out because I want it in factored form, because I want to get rid of my common factor on top and bottom. So up on top, I have 3x plus 12. On the bottom, I have negative 10 minus 5x. Notice how I continue to write my limits because I have not taken the limit yet. Okay, here I have a negative 2x and a plus 2. We're getting there. Okay, up on top, I'm going to factor out a negative 2, because if I factor out a negative 2, I'm going to get an x minus 1, which that's what I've been looking at getting rid of. So I'm factoring out a negative 2. And I can finally cancel this out. And we can cancel it out because x is not 1. And we're left with negative 2 on top. Now I'm putting the 1 in for the remaining x's. 5 times 5, so negative 2 over 25. Took a minute, but there you go. Number 44. If I put a 4 in for x, I have a 0 on top, and I have 2, 6, which is a third, minus a third, 0 on top, 0 on the bottom. So there's a hole. I have to get rid of the hole. I'm going to multiply top and bottom by 3 times x plus 2. Those are my two denominators. This time up on top, I'm leaving it. I'm not going to distribute up on top because it's already factored. I want it factored because something is going to reduce. So don't distribute. You're trying to reduce one of those terms. In fact, you're trying to reduce that term right there. Okay. X plus 2 reduces with x plus 2, leaving 2 times 3, which is 6, minus 3's reduce out, leaving 1 times the x plus 2. Be careful because we have a minus there. Either distribute or keep that x plus 2 in parentheses. So this gives us 3 times 4 minus x times x plus 2 over 6 minus x minus 2 which is 4 minus x. The 4 minus x is reduced out, leaving a 1 on the bottom, and again we can reduce it because x is not 4. And now we put the 4 in for the remaining x's, and we have 3 times 6 over 1, which is 18. And there's page 2.